This right here is LegoMario. He got released as part of a collaboration between Nintendo and Lego in the summer of 2020, and it's primarily a kid's toy. However, at the start of 2022, I discovered a video by Bruno Hautzenberger that showcased a Python script communicating with LegoMario, and I got hooked. I expanded on Hautzenberger's script by building a GUI on top of it and also coding a lot of fun projects of my own that can really showcase the power of LegoMario. I have published all of them, and I'll walk you through them in this video. For example, you can build a soundboard on your computer using Python, including LegoMario. Or you can use LegoMario to play Super Mario 64, you know, by tilting and jumping with Mario himself. And you can even integrate LegoMario into the pygame library, which is like one of the libraries to program games with Python. But first up, we have to understand how this bad boy even works as a toy. Mario uses 3 sensors to report on the environment around him. First up there is a camera at the bottom of Mario that can read the color of ground below Mario, as well as recognize certain RGB codes printed on enemies and the likes. Next up, we've got 6 little pins hidden below Mario's pants that get pushed in by the pants to allow Mario to recognize the type of pants that he's currently wearing. Notice how it changes to Luigi as soon as I put on Luigi's pants. Lastly, we've got an acceleration sensor that sensors Mario's acceleration in each axis of the 3D space. So now that we know all about Mario's sensors, let's see how we can use them. What's on your screen right now is me trying to play Super Mario 64 as best as I can using only LegoMario as my controller. I really wanted to combine the LegoMario experience with a native Mario experience, and I think using him as a controller is really neat. Since the acceleration sensor measures gravity as upwards acceleration at all times, we can use that to our advantage and roughly calculate the angle that LegoMario is currently being held at. Combine that with upwards movements for the A button, forwards movement for the B button, and downwards movement for the Z button, and that makes for a perfectly fine Super Mario 64 controller. Although, while I say perfectly fine, I haven't fine-tuned the motion controls, so you will not always execute the movement that you intended to. That being said, I got pretty good with it after a bit of practice. While there is a download link already in the description, I'll also upload another video soon explaining the entire setup of the controller. Next up, I'd like to talk about these Lego tiles. They come pre-printed with color codes, so Mario can easily recognize them. Which gave me the genius idea of assigning each tile a different sound to play. Next up, they come pre-printed with color. Yeah, alright, that final bit actually wasn't the soundboard. But while you're here, let me explain to you how the soundboard actually works. Once started, it creates a folder for you to put any number of wave sound files into. And once you've done that, you confirm it, you select an audio device. And as soon as LegoMario is connected, the script will play your sounds back to you one by one and expect you to scan one tile per sound to register that sound to the tile. Once you're done registering all your sounds, you can use the soundboard. You just scan the tile and it will play back the sound for you. Now let's get into my last, but in my opinion most important point about LegoMario: creating yourself. Pygame is Python's largest library for coding your own games, and with my integration, everyone can now use LegoMario in theirs. Like in this example, where you control a rectangle and have to avoid getting squished.